So for question number 19, we're going to be discussing the Aufbau Principle, Pauli Exclusion Principle, and Hansool. So we're going to start with the Aufbau Principle. So this principle states that you always fill the electrons, the orbitals, with the lowest energy first, and then go to the highest energy. For the ground state, you'll learn when in excited states how this rule is not always followed. You can always follow this rule by using the chart I drew in problem number 16. So 1s is the lowest energy orbital. Then you go from 1s to 2s to 2p to 3s to 3p, 3d, 4s, 4p, 4d, 4f. So that's the order from lowest to highest. So if you ever need to remember which ones are the lowest and what's the order, you can just draw this useful diagram to help you. The next principle is called the Pauli exclusion principle. So Pauli exclusion principle is basically what it says is that for each orbital there's a maximum of 2 electrons. So if you remember when we talked about the spin quantum number, there's only plus 1/2 and minus 1/2. So therefore for any orbital there can only be 2 electrons, the plus 1/2 and the minus 1/2. For the last one, this is called Hansool. So Hansool states that electrons will always distribute between orbitals of the same energy at ground state. So let's do an example where we need to follow Hansool. For example, if we're in the 2p orbital, remember with 2p, the azimuthal quantum number is 1. Therefore, for the magnetic quantum numbers, we have -1, 0, 1. So we have 3 orbitals. And in each of these orbitals, we have a possibility for a maximum of 2 electrons. Pretend we only have 3 electrons. How do we distribute them evenly? Well, that means that only 1 electron can go in each orbital. We would never put like this, with 2 electrons in one and then no electrons in another orbital. We would have to distribute them evenly, like so. However, for example, if we have 4, now we just have to leave it like that. If we have 5, we can put it here, and then 6, the maximum number of electrons that the p subshell can hold, would go like that.